the #1 digital content creation package in the world. 3dsMax is unambiguously the most important 3D modeling and animation package in the world. Almost every single important game, every single important movie is somehow touched by 3dsMax. There's over 300,000 users, known users around the world. This is a package that is used by literally every important game developer and every important movie studio. It's also increasingly used by companies that are using it for architectural simulations or architectural renderings. These projects are becoming so grand and so expensive. In order to compete for those very limited jobs, architectural firms have to put their best foot forward. They have to help their clients visualize what the project is really going to look like. A sketch is no longer good enough. You have to help them visualize it and feel it in a photorealistic way. Now, we've been working with Autodesk and especially the 3dsMax team for quite a long time. We worked in areas related to Quadro for interactive previewing. We've worked in the area of mental ray, the first ray tracer that has been incorporated into 3dsMax. Today, we're going to announce a giant step forward in our collaboration and introduce to the world a capability that it's just never seen before. To help me introduce that idea and make that announcement, I'd like to welcome Ken Pimentel, Mr. Marketing for 3dsMax, and Michael Kaplan. Good to see you, Ken. Michael, welcome. Good morning.
Hi.
Michael is one of the brains behind what we're about to see.
Definitely.
Well, before we get going, why don't you guys tell us a little bit about 3dsMax and let's see, we're going to pop it on the screen, right?
Yeah, we can show the monitor
Maybe if
here,
they could just see 3dsMax. This is what 3dsMax looks like. And Ken, help us understand, what do people do with 3dsMax?
Well, they do a lot of different things. And in this case, we're showing you the viewport for 3dsMax. This is where an artist would create their reality, move things around, and set up the vision that they want to show to their stakeholders. Mm-hmm. So what we're going to show you here is a typical scene that an architect might be working with. This is an indoor scene. And what they want to do is have a photoreal experience for their important stakeholder that's coming to meet them. So they've hit the rendering button. And
so the first thing you do is you simulate, you capture the 3D scene, the geometry of the scene. And of course, you have to place onto it textures, and you got to program.
You got to dress it up,
dress it up.
It comes from tools like Revit and AutoCAD or an Inventor, bringing all this data in. And then in 3dsMax, you aggregate it and dress it up and create something more real, and bring the person into the design through photorealism. And
at some point, you're happy with your design.
Yes.
But you're still not sure. You just want to preview it and
right.
To see what it's really going to look like. And so you have to do a photorealistic render.
Exactly.
And so back in the good old days, we would either look at it like this in a wireframe mode, and then, of course, in some of our earlier collaborations, we could actually render this with textures and
right.
shading. But it's not photorealistic. No. It's about as photorealistic as a game.
Right.
And so we know it's not photorealistic, and at some point, mental ray was incorporated into 3dsMax so that you could do that photorealistic rendering right. using ray tracing.
Right.
And so I think, Michael, you're going to show us now what you just popped up earlier.
Right.
That's mental ray doing ray tracing.
Mm-hmm. And I started this process at the beginning of the keynote about an hour ago.
Uh-huh.
So simulating reality is a very computationally intense problem. And customers, the only solution to it has been in the past that we have to cheat. We have to figure out ways of simplifying the process, doing interpolations to maximize what a CPU can do for us.
Speaking of CPUs, at the moment you're currently rendering on what? This is a workstation right here.
This would be a typical workstation that our users would have. It has 2 dual quad-core processors. Mm-hmm. So, that's a lot of horsepower, and it's required even to get, to simulate reality.
And in fact, rendering is one of the most computationally demanding parts of content creation today.
Indeed.
Absolutely.
Right?
Yes,
And so this is a Mental Ray. This is a product that was revolutionized by Mental Images. Michael, this is how many years ago that Mental Ray came out?
20 years
20
ago.
years ago,
Yes.
right? And it was one of the world's first ray tracing.
First photorealistic ray traced renderer.
Uh-huh. And so you said it earlier, but I wonder if everybody picked it up. You launched Mental Ray to render that scene
To render one frame an hour ago.
at the beginning of our
And
keynote.
you can see it's working on 16 cores 100% of the time, and it just filled in another piece of information.
Uh-huh.
But Mental Ray, even in this case, is using interpolation and other approaches to sort of fake reality. It's not doing a real physical
Well, if you had to
simulation.
fake reality, everybody would want to fake it differently, right? So you guys probably give the user a lot of control.
Right.
Is that what you guys would do?
Yes. So another big problem when you want to simulate reality has been that these rendering systems, because they use interpolation and different techniques to accelerate things, they have a command panel that looks like you're flying a 747. I mean, there's so many dials and settings and parameters that you can use to adjust the faking of the reality.
And so I'm an architect. I just want a photorealistic render of this
Exactly.
room. I don't
Right.
want to be an expert in computer graphics.
Exactly. Yes.
Right? And so in order to use Mental Ray, you have to be familiar with computer graphics enough to be able to enter this panel with all
Yes,
these parameters.
yes, yes. And it's a science that they don't really want to learn. So what's unique about including iRay in 3dsMax is the setup. So if we can switch our rendering, so we're going to switch from Mental Ray, and we're going to switch over to iRay.
And so this is something that some of the audience, wrong.
Yeah.
This is something that some of the audience have heard about. It's a technology called
iRay.
iRay. It is the world's first physically correct photorealistic renderer.
Right.
And it's completely GPU accelerated. And you guys are announcing today
Yes.
that iRay will be part of the 3dsMax package.
For subscription users, next week they'll be able to start downloading iRay and PhysX to be able to actually do these things we're going to show you right now. Now, I
Okay.
think one important thing to stress is you've been talking about simulation for science
Yeah.
and all these things. Here, we are physically simulating every photon as it passes through the scene. We're not interpolating. We're actually doing the real hard part of the problem, physically simulating reality.
And this is for the audience that isn't as familiar with computer graphics. This is an area that we've wanted to innovate for some time, which is to move from computer graphics, traditional computer graphics of rasterization and other techniques to fake, if you will, as Ken was describing, the imagery on the screen. We want to move towards computational visualization, computational graphics. And so using computer techniques, just as you use for computational fluid dynamics or computational molecular dynamics, we want to move towards a computational techniques as well ourselves. Now, Michael, you're one of the brainchilds behind iRay. Tell us about, what is you worked on Mental Ray before, you worked on iRay. What is the breakthrough about iRay? What's the big deal
the big
about
breakthrough is, as Ken said, that we're able to actually simulate light physically by tracing every photon in the scene. And in order to be able to do that, you have to model the interaction of the light coming from a variety of light sources through materials like glass, bouncing off of things, being refracted by the glass, being absorbed by materials, being transmitted and blurred out by materials, semi-glossy materials. And to do this requires an enormous amount of floating point computation. And then to make it really work properly, you have to simulate billions and billions of samples. You have to sample all sorts of multi-dimensional space to make this work. So to do the sampling in the past was just not really practical on a CPU unless you had a supercomputer, because you just did not have enough floating point computation on the desktop to be a useful process to do this kind of visualization. So in the past, it was always done through interpolation techniques where they sort of work, but you have to know exactly how to set them up. And no matter how well you do at the end of it, you may not get the result that you want.
I see. And it's because they sort of work. Everybody's scene and because everybody's subject is a little bit different.
Yeah.
their scenarios a little bit
Every
different.
scene is
You
different.
might find that what used to work for one scene no
Yeah.
longer works for this scene, and you got to tweak
Right.
it a little bit more.
All
and that's
of
why you have
those
to become an
settings
expert.
you saw before were set per scene and even maybe per view.
And so in the case of iRay then,
Yeah.
all of the material inside the environment would use
Real
this
world.
technology called BRDF.
Correct.
Right?
Real
Bidirectional
world.
reflectance.
Real-world materials, real-world lights, and real-world design. Much like ANSYS does on the physics side.
Trying to simulate the world.